you're learning how to combine like terms. So it's like x squared plus y squared in parentheses plus 2x squared plus 3y squared.
All right.
And keep in mind, the parentheses are only needed when there's an operator that does something. So like the plus doesn't do anything to these things inside here. So they're essentially not needed. So one of the skills here is getting comfortable with the idea that you don't need the parentheses, or if there is a subtraction operator, what to do with that. So now you get to combine like terms, okay? And this is where most students struggle, because you have to visually see like what is a like term. These are both x squareds. And these are both y squareds. Okay, so they obviously go together. I used underlines. You can underline, you can circle, you can overline, anything you need to do to make it clear, like, hey, these are the same. And one thing I recommend is crossing them out as you combine them.
Okay.
That way, you know, hey, I've combined them here. All right, so let's take a look at another one here. Let's make this one a little more complicated. And then we'll move to some harder stuff here. Actually, yours aren't even that complicated, so let's not do that. Let's go 3 plus 2x plus 4y plus 4 minus 3x minus 5y. So again, the parentheses are only needed. They are only needed if there's a subtraction operator. So since the plus operator here is here, and there's essentially a plus operator, excuse me, over here on the left.
All right.
You don't even need them. So I would write it without the parentheses. Now, another small point here is that the operator always goes with the thing. So it's minus 3x. It's not subtracting 3x, it's really minus 3x. Same thing over here, it's minus 5y. The operator goes with it. We don't generally say like plus 4, but the 4 is positive.
All right, so yeah, positive 4.
So 3 and 4 combine to what?
7.
7. Now I'll use an overline. 2x and minus 3x, what do they combine?
Negative x.
Negative x. And then 4y and minus 5y. Notice I circle the operator. What does that become?
That means that we have to subtract it.
Yes. So what do these become?
Just negative y.
Negative y. Excellent. Okay. So now on to the more interesting stuff, which is subtraction. Let's say it's minus 3x squared plus 2x plus 1 minus parentheses 4x squared minus 3x minus 2. These are the ones you're going to see on standardized tests. These are the ones you got to get really good at. There could or could not be parentheses here, but again, because there's a plus here, they don't. There's nothing to hold the parentheses. The parentheses are held there when you actually have to do something to it, like distribute a negative or multiply or even divide.
If it doesn't have the parentheses, I should like think of it as if there are parentheses.
No, I'm sorry. That's not quite right. What I meant is like sometimes you see it here in the beginning and they're really not needed. Like if you look at,
sometimes it isn't.
Yeah, they're not even implied because they're unnecessary. Now here, this is where students get really into bad habits, and I want to make sure that this doesn't happen with you. This negative applies to 1, 2, 3 terms. So this is a term, this second circle is a term, and this third circle is a term. The term the term is 4x squared. And when subtraction here, subtraction means to negate. It means to change to the other. And hopefully you saw this in class. So like this is positive, so it becomes negative 4x squared.
Positive 3x.
Positive 3x. Positive 2. Okay.
So then would I just leave it as that, or would I keep solving all of it?
We got to use some right words here. So you are simplifying.
Simplifying.
Solving requires an equal sign.
Okay. Simplifying it. Simplifying it for the answer.
Yes, you're simplifying it. The instructions will say to simplify or reduce or something else. Okay, so now you got to combine like terms.
So
That's why I said term. So like this one and this one, what does that
to,
become?
negative 7x squared, or would I just say negative
Good.
7?
No, they're it's like saying -3 things, -4 things. The reason they're the like is because of the x squared, not the number in front.
All right. So minus 7x squared.
How about 2x and 3x?
Plus 5x plus 3.
And then 1 plus 3. Okay. All right, so I'm gonna give you another one. You got this written down?
All right.
It's okay if you didn't. I can keep it up here, but I'm gonna write down the next one here. So
All right.
2y cubed minus 3y squared plus 4y minus 5 minus 6 plus 2y minus 3y squared plus 4y cubed. And this is your practice problem. I'd like you to try and do this one on your own. The reason it's more difficult is because you showed me you can do this. So I'm going to just mute myself for like 60 seconds and I'll check back in with you here shortly.
All right, sounds good. All right, I think I'm all done.
Okay, if you're doing it that fast, I'm going to do it fast too.
All right. Yeah, I think I got the hang of this pretty well. I just wanted to, I didn't know what I was going to expect. So I was like, all right, I'm just going to make sure we have that weekly meetup this week. And
Yeah, there was always plenty to do here. So here's the final answer, minus 2y cubed. And notice I'm going to cross these out as I do them because that way I can minus 3y squared and 3y squared, they cancel out. 4y and minus 2y becomes plus 2y minus 11. Is this what you got?
minus 2. Yep, that's what I got.
Okay, exactly this, right? Okay.
Exactly that.
All right, so you're well on your way here. Okay, so let's talk about multiplying polynomials.
All right.
So the reason something is called a polynomial is because it's got more than one. So there's monomial, which is one term. Did you see that in class? Binomial is 2 terms. Trinomial has 3 terms. And then polynomial is more than one. So like these are also polynomials, but after 3 terms, it loses a name.
Mm-hmm.
So
I remember the teacher going over that a little bit.
Okay, so here's a basic like thing. X times x squared plus 3x cubed. Okay. All right. So this is like distributing a negative. You're distributing the x to both. So this is like x times x squared plus x times 3x cubed. Okay. Now, when they have the same base, there's a property. So the property is if you have x to the n times x to the m, these have the same base, this equals x to the n plus m. So here on the left, you add the exponents, that's x cubed.
X cubed.
X to the power 3 because it's 1 plus 2 equals 3.
Okay, and then
now on the right here, you can do multiplication in any order. So this can be x times x cubed times 3. It's the same thing here. You got the same base, so you add the exponents. 1 plus 3 equals 4. This is x to the 4th. Now, by convention, you tend to put the number in front first.
Okay, so do I
so this is it. This is your final answer.
All right, so you have the x to the second power or here, I'll do the other one. So you have like the 3x to the third power. So then you use the x going into the 3x and you add 1 to it. And then it's like 1 plus the third power. So then it becomes like to the fourth power or
Yes,
however.
yes, yes.
Okay, all right.
So let's
I
try
thought you
another
did
one
that
here. Let's
once or
try another one
twice.
that's like this. Okay. Let's say it's x squared times 4x plus x cubed.
X squared or x plus x cubed. All right.
So you're going to distribute this in to both. So it's x squared times 4x plus x
Cubed.
squared times x cubed.
Okay, so then I'd be bringing in 2 plus the 1.
Right. So you know the 4 is just over here. So it's 4x cubed because 2 plus 1 is 3.
3. And then would that other one just be x to the 5th power?
Yes.
Okay.
Okay, so now we're gonna slightly increase the difficulty here. You can have both a number and a letter on the outside. So you can have like 2x times x to the 5th minus 3x squared.
All right. So I guess that'd be 2x to the 6th power
Okay.
and negative 6x to the 3rd power.
Yes. Excellent. Okay. So you really got this. So I'm gonna increase the difficulty here a little bit.
Alright.
So let's say I'm just gonna make this one a lot harder. 2xy, and you're gonna see if you get it or not. 3x squared minus 4xy plus 2y squared. And I'm just going to let you go. I'm going to see if you can get this one, because if you do, you truly do understand. So we can move on to the more important stuff that would be helpful to you.
All right. All right, minus 6x to the 4th power, just y. So like minus 6x to the 4th power y. And then positive 8 x to the 2nd power and y to the 2nd power.
Okay, keep going.
And then negative 4 x and y cubed.
Good. Wow, you actually do really understand this.
Okay.
It's very refreshing because there's a lot of little wrinkles there that could throw you off.
Yeah, I think
Okay.
I did Kumon for a while when I was younger. I
Okay.
feel like
So
I
this
was
is
something like this right before I stopped.
a monomial times a trinomial.
Trinomial.
Okay,
Right,
but
1, 3.
and this is nice, but what you're really going to get is something like the following: x plus 2 times x minus 3.
That's what I was doing in class.
Great. That's where we're getting to. So this one has a method called the FOIL method, and these stand for these letters stand for certain things. Let me send you a link real quick
Alright.
to a reference sheet that I have that may be useful to you, but at least let me get it over to you.
Will that just be through the chat or will that be through email?
I'm going to send it right through the chat, and then I'll also send it later on through
All right, so
through email. So this is a it's the FOIL reference sheet.
FOIL reference sheet.
And I like one-page reference sheets, but it'll explain what we're about to do, and it's much more visual. So actually, I might as well snip that in here. Just a moment here.
FOIL reference sheet. Open. All right. Should I write that down, you think?
it's something you're going to know before too long. So I actually chose this almost the same example. The
All right.
key
By the
here,
way, I can't like for whatever reason I can't see your like Zoom, like the Meet itself. I just see introducing Zoom apps. So I'm gonna click like back a tab
okay,
and
uh,
just if it kicks me out, I'll join back in like 10
sure,
seconds.
sure. Make sure you can get back to where you can see the screen,
All
please.
right. Okay, I can see the screen.
Great. So the FOIL method, it stands for first, outer, inner, and last, and it's the order that you multiply.
Mhm.
Okay, so first the F here, and this we're probably going to do a couple like this, means x times x, which you now know is what does x times x become?
X to the second power.
Right. The outer is x times 3, and
Which is only 3x.
by conventions that the inner
2x,
is 2 times x, or 2x, and then the last
would be 6.
is is 6. It's 2 times 3, which is 6. Now in general, but not always, you can combine the outer and the inner. These are often like terms, often, not always. So this becomes x squared plus 5x plus 6.
All right.
Okay, so let's have you do one on your own here.
Sounds good.
I'm just going to make one up here. Let's go x plus 4, x plus 5. Go ahead and give that a try, please.
All right, sounds good. Oh, there's like the like terms of this one.
Yes, absolutely. So
Then
this is a good turn. This is a good use of our lesson time here.
all right, x squared plus 9x plus 20.
Yes.
All right.
Okay, so give me just a moment here. I want to pull up a worksheet on this that I think will go through some examples and really help here.
Oh, sweet. Yeah, this is like pretty easy to me. Like this all just like makes sense.
That's good. I like hearing that. From my perspective, I often hear this is impossible. Can't do
Oh,
it.
geez. Oh man. Well, I'm glad I'm one of the few who's opposite.
Yeah, you're on the ball here. That's
Yeah,
interesting.
basically like just what we were doing in class was like this, but it was just like even longer, like it would be up to like 5 in like one parentheses for each. So then it's just like it's not really hard. You just have to like write a lot for it. So
Right. All right, so let's try another one here. This one's slightly different. I'll let you see if you can work through that because it's
all right, X. All right, x squared minus 12x plus 35.
so I had a teacher in 8th grade who said he told everyone in the class that he was going to hold up a 3x5 card with what's on the left here, and he expected us to produce what was on the right here in under 10 seconds. Do you think that's possible?
I think so, but I have one question before.
Sure. Yeah, sure.
Is it negative 35 or positive 35?
Okay, so I'm going to answer your question with a question here. What is -5 times -5? Because remember, this operator always goes with the number. I'm sorry, 7. What is -5 times -7?
Oh, okay, yeah.
Positive 35. Okay, so I wrote the wrong thing.
Oh, okay, all right. I didn't know if I
Sorry. I got really excited about that. So,
oh no, you're all good. But the 10-second thing, I think I could probably do it in 10 seconds.
okay, I'm not going to challenge you with that right this second because I want us to do a few more samples. But
Okay, sounds good.
But you can download this worksheet I'll send you, and you can try it out on your own if you want. So let's try another one here. Let's try this is another case. It's called x plus 12, x minus 7.
X plus 12, all right. Yeah, one thing I like about this is like the way you wrote it for the first one for one of these, because before I was like writing it in this like much longer way instead of kind of just doing it on top of each other.
Yeah, like the way I want you to be able to do this is x squared minus 7x plus 12x minus 84. And eventually I want you to be able to just combine the outer and the inner together in one step.
All right, so I got x squared plus 5x minus 84.
Should be plus 5x.
Plus 5x. Oh, did I say minus 5x?
You did. Now maybe you wrote the right thing.
Yeah, I wrote plus 5x. I don't know, I said minus.
Okay. Let's try another one here. Let's go, and then we'll increase the difficulty here. I mean, we can always do that. I can introduce other variables like t plus 9, t minus 11.
Okay. Okay, t squared minus 2t minus 99. Would an easier way to do it also technically be like you could look at it as just t. Oh, wait. Are you muted right now?
Yes, thank you.
Oh,
Do you see how the first term and the last term can be found very quickly?
Yeah, you can just look at it like just like that, and it makes
Right.
sense.
So it really comes down to O and I for how fast you can do it. And you're supposed to say, oh, 9t minus 11t minus 2t.
Minus, yeah, okay. Yeah, I think that's how I was doing it in class earlier today, but I was doing the like middle part wrong. I just made it like I think I'd always make it like positive too, like I'd look at it wrong.
Okay. So let's try this one. How about x minus 2x plus 3 times x minus 4? So this one's a little bit harder, but you can still do the first and the last very quickly. 2x squared and then minus 12. But the inner and the outer a little more, you have to hold it in memory a bit more. 3x minus 8x.
All right, would it be 2x squared minus 5x minus 12?
Yes. So let me give you one here to do on your own. Let's come up with this. So 3x minus 2 times x plus 5.
All right. All right, 3x squared minus 13x minus 10.
Okay, so when I multiply the outer, I get 15x.
15x.
And the inner is minus 2x.
Wait a second, what did I get wrong here?
Maybe you said it wrong. This is the right written answer.
Minus 13x
plus.
Oh, that's what I had. Oh, plus. Maybe that's what I. Okay. Yeah, I had all.
You good?
I don't know what I did there. Oh, so 15x minus 2x.
Well, that's okay. What we're trying to get at here is just do enough examples here that you fully trust yourself to do these correct.
All right.
So let's do another one. Let's do a 3r minus 5 r minus 6.
All right.
So again, that first and that last are pretty straightforward. They're
Yeah. I was just double check everything.
so the outer is minus 18r.
I got 3r squared minus 23r plus 30.
Perfect.
All right.
Okay, let's try another one here. So notice now I can always add coefficients in front of both.
Mhm.
But really all that, it doesn't change the first. The first is still whatever it is. It's the outer and the inner that just get a little bit incrementally more
Mhm.
sophisticated, complicated, whatever.
Two. All right. 20q squared minus 17q minus 24.
So the outer is 15q and the inner is minus 32q, so minus
Mhm.
17q. Is that what you got?
Yeah.
Great. They're not any more complicated than that. There's just more practice to be done if you want it.
All right.
And obviously you can make the numbers larger. So like, how's your multiplication table? Like, do you know like 13 times 12?
I think I know just up to the 12s.
Right. So this is where like,
156.
say that again.
Would it
Yes,
be
yes,
156?
yes,
All right.
yes. But like there's a million of these, right? Like there's like 7 times 17. And you just, this could be a test on, do you remember some of those or can you quickly find it?
Mhm.
Okay, so another thing that I saw um, in your email, and it's kind of towards it's towards the bottom, there's the exponent rules. Okay, and we've covered a couple of them, but let's spend a little time there, as much as you want here. So let's say I tell you that x squared to the power of 5. There's a rule that says if you have, well, you use a, so let me use a to the m to the n equals a to the m times n. So whenever you have an exponent to an exponent like this,
So do you add or multiply that?
multiply, you multiply.
Okay. So,
So not to be confused with what we were doing earlier, right? There's
mhm.
only one base. There's only one base,
X to the
x. Okay. So what is y cubed to the power of 8?
Y to the 24th power.
Okay. How about z squared to the power of 3?
Z to the 6th power.
Very good. Okay. So the first few are actually pretty easy to like get down, and then we'll go to the next one here. So the next one is x squared y cubed to the power of 4. And again, over here is the rule. If you have a times b to the m, now keep in mind there's really a 1 there and a 1 there. It's a to the 1 times m, b to the 1 times m. And I write the ones there because you're not going to get a 1 there. You're going to get like a 2 and a 3, and you multiply these numbers. So here you multiply the 4 times 2 and the 4 times 3. So what does this become?
12.
4 times 2 is?
Oh, 8.
And y to the power 12. Good. So let's have you try one. Let's say it's z to the fifth, y to the eighth, all to the power of 2. What does this become?
That becomes Z10 Y16.
Excellent. Okay.
Okay.
So that's all well and good. And now we have to throw in what's called synthesis. And synthesis is like got a couple of things are combined together. So what is 3x squared to the power of 2? And before you answer, what is the exponent of 3?
X. Oh, 1.
1. So a number has an exponent, right? It's also being multiplied by 1. It's also being divided by 1. But we never write any of that. But you have to know that. You have to know that that exists. So now this 1 is multiplied by 2. So this is 3 squared x to the fourth power,
Fourth
right?
power.
2 times 2. You wouldn't leave it like this. This is 9x to the fourth.
9x to the fourth. All
Yes.
right.
So you try one here. What is 4y to the fifth to the third power?
4 third y to the 15th, and then it would become 64y to the 15th power.
Yes.
All right. That's just a memory thing.
Now there's a let me grab something real quick here to show you. Just a moment here. There are some of these exponents that I think are worth memorizing. And here's the value of memorizing them. It saves you time. So the faster you know the exponent or the number, the faster it is on a test. So what we just did is 4 to the power of 3. That's 4 to the power of 3. Do you see that?
64.
Yeah, and these are like the recommended ones that I think are reasonable to get at. Okay.
Mhm.
Meaning like you should know 7 to the third, but not necessarily 7 to the fourth. You should know 6 cubed is 216. 6 to the fourth, maybe not. Anyone's on the edge here are kind of questionable, but everything else, like you want to know fast. You want to know that like 3 to the fourth is 81. So 3 to the fifth is 243.
All right. 3 to the 8. All right. Just so get those kind of down, like.
Yeah,
so-
it's I mean, some of them you already know, but what you do, the last thing you want to be doing when you're finding 2 to the ninth is go, okay, 2 cubed is 8, 2 to the fourth is 16, 3. Like that takes too long. So
Yeah.
it's just a time thing. Okay.
Mhm.
All right. Now, the rule that I just showed you up here, this rule right here, it's not really the complete rule because what if I put a C in here? So what if it's A times B times C to the M? What do you think that is?
I guess A1, B1, C1.
So it doesn't matter how much stuff is in here, it all gets the M. So let's say it's 4x squared y cubed z to the fourth all to the fifth power.
Mhm.
How many of these get the fifth power?
All of them.
All of them. So
So
give me
that
your final answer here, and you're welcome to. I'll tell you that 4 to the fifth is 1024.
1024. All right, thank you.
Yep.
I would have taken a little bit.
Great.
1024 to x to the 10th power y to 15, right? I was like thinking about doing like how we multiplied the 4 and then z to the 20th.
Okay. So what happens here is you got to remember, like, this is multiplied, this is multiplied, this is multiplied, and then all of a sudden you get a problem like this. Hey, what is x squared times x cubed?
That is x6.
It would be if you're multiplying those, but when you have the same base,
Oh, 5.
you add them. And you said 6 because you've been doing so many multiplications, and that's why that happens. So really pause and be sure you know what it is. So now let's look at the same example here. X squared times x cubed to the power of 4.
All right.
There's two ways to do this problem. The first way is to work on the inside, and the second way is to work on the outside first.
All right. Would it be 4x to the 8th power and then 4x to the 12th power?
Where's
Or-
the where you're telling me about a coefficient? There's no coefficient here.
Okay, so it just stays as x. I guess so it's like x to the 8th power, x to the 12th power.
Okay, so you're choosing to apply this first.
Is
Okay.
that not the right way to do that?
It's completely correct, but I'm going to show
Oh.
you there's two ways. So now the bases are the same and you're multiplying, so you add the exponents.
So it's fine. Oh, so you could technically add 2 and
So
3.
So
and
let's
then,
do that first. That's x to the 5th to the power of 4.
which is then x to the 20th.
And are these the same?
Yes.
Yes.
Okay, so there's like
So
no like they both
there's no order of operations here. There's preferences. There's like, this might make more sense, but there's no like rules. You actually have a little more like choice in this matter. It's not like, no, you must multiply before you add or whatever. It's there is no order of operations here. Okay, so final little thing here. Let's say I give you negative 3x squared. Okay. Now don't try to apply any rule here. Let's be more literal. This means negative 3x times negative 3x. Do you agree with that?
Mhm.
That's negative 3 times negative 3, x times x. Negative 3 times negative 3 is 9. X times x is x squared.
All right.
Why do you think students write minus 9x squared as an answer here, which is wrong? This is wrong.
Maybe because like they think it's like, oh, I have to make like 3 times 3 and then square the x, and then I guess they forget that like when there's a 2 in the negative, like it'll, if it's a positive or an even number, it'll make it positive.
Yeah, so all those are possible here. There's a couple of ways to look at this, and I'm going to give them to you. One way is that this is negative 1 times 3 times x squared. And furthermore, these are in parentheses.
Mhm.
So it's parentheses negative 1 squared, parentheses 3 squared, parentheses x squared. That's like way one. Way two is the way I really want you to do it, which is to realize that negative 3 is in parentheses
Mhm.
and x is in parentheses.
Okay.
That negative goes with the number.
So then that would become 9 and then
X squared, which is what that is. And this does too. This is also 9x squared, but you get into some weird situations. This is very often forgotten, but this is a number and you're squaring it. You're multiplying negative 3 by itself.
Do you think you'd be able to like just put like a square box around the way you want me to do it, please? For like when I
Oh, sure. Well, the more math you take, though, the more choices you get.
Mhm.
Okay, so let's say negative 2x squared y cubed to the 3rd power. Actually, I'm sorry, to the 4th power. Let's do that.
Okay. So you have to get
Give that a
negative
try, please.
2 and negative 2 to the 4th power, x2 to the 4th power, to the 4th power. So then you'd get okay, 16x to the 8th power, y to the 12th power.
I heard 16 x to the 8th power y to the 12th power. Totally correct.
Okay, sweet. And I just did that the way that you said you want me to.
Yes. All right, excellent. So this would be a good place for us to stop, if you would like. This does cover everything and a bit more that you wanted to cover today.
Yeah, this was great.
Excellent. Okay, so I'll send you the notes and the screen recording out shortly. Thanks again for scheduling, and I'll see you next time.
All right. Yeah. Thank you so much. See
You're
ya
welcome. Bye now.
later.